I won't start over because we just don't have the time. So in order to mitigate this manual software management, which very many scientists do instinctively, perhaps because they think they're doing stuff the easier way, very many of the software providers actually supply bundled software packages with like everything you would ever need. This actually makes the entire research workflow and the software even worse in that, in addition to making it unreproducible because people do it manually and forget what they've done, it also makes it very intransparent. Like it becomes this huge dependency black box, which nobody really knows anymore what's inside there. And of course, one of the biggest problems are the legacy stable systems which you use for research. Very many of the bigger servers or like data analysis machines, a lot of universities want them to stay the same so that you can do the same work again. But because they don't have any sustainable system to like keep everything reproducible, they usually do this by freezing the system and keeping it at an outdated status forever. This is especially poignant with like very, very big software clusters which don't get updated except for like the most critical security stuff, and the research software is completely out of date. It's of course not all that bad. There are some initiatives to make this better. One of the most notable ones is NeuroDebian, which provides pre-built binaries of unbundled data analysis software for neuroscience on Debian, which is why it's called NeuroDebian. Also, very many scientists all resort to using containers, Docker containers, in which they just take the status of their machine when they executed the last data analysis pipeline and save that and distribute that as a binary. Needless to say, this also has the disadvantage of not being scalable, because how many Docker containers, like for each and every publication, could you ever save? There's also stuff like the Canadian Brain Imaging Research Platform, which is a platform in which the software is well managed and kept reasonably up to date. But the problem with this, of course, is that it doesn't give the researcher any autonomy. You want new software, you have to contact this entire bureaucracy. And worst of all, in order to use all of this software, you have like this predefined GUI, which might not even accommodate your use case. So I'm saying that these things are not bad. I mean, I've worked with a number of the people who work on NeuroDebian, on CBrain, and they're doing good work. They're pushing research forward. But the problem is that the needs of research are very, very advanced. You don't just need stuff which is not bad. You need a lot of features. And for those of you who speak German, this is the eierlegende Wollmilchsau. It's like a Larry the cow, which can do everything. And this is what research needs. On the one hand, they need data analysis reproducibility, which might be contingent on a software environment reproducibility. On the other hand, researchers really want autonomy, because you're working on developing new ways of looking at data. You want to be able to manage your software the way you think is right. And not least of all, perhaps going hand in hand with this point, researchers want access to development software, because very many of the researchers, especially in the neurosciences, but I guess it's the same in other fields as well, are user developers. They develop their data analysis tools, and they need access to the live versions. And of course, you need to implement this on a multitude of machines, because people might want to do the research on their physical machines, they might want to do it on virtual machines, which they can spawn in the cloud, or they might want to do it on the shared clusters of the university. So based on my prior experience with Linux, I set out a plan to tackle these like 3 implementation points, which can be summarized in 3 very simple, very beautiful words: Gentoo, Gentoo, Gentoo. Actually 4 words, because it's Gentoo prefix. You can't really use the Gentoo on the cluster unless you can convince your university administration to let you install that, which likely you won't. And the advantages which I think Gentoo can offer for this workflow, or at least what it offered me, was that it gave me very easy software environment replicability. I have a lot of machines in which I try to do similar data analysis pipelines. My physical machines, my clusters with the University of Zurich, my clusters with the ETH Zurich, sorry, not my clusters, my virtual machines. And by transferring a small number of simple portage text files, I was able to reproduce the same software environment which I needed across all of these machines, directly from source with the Neo software. Not only that, but in cases where I needed to make sure that not only do I have the same packages, but the same versions, I could do that via one of 2 hacks. Either I could move my portage snapshot, which is a bit more intricate, or I could just detail the exact version limitations which I wanted via the package mask file. And this, at least for me, addressed the main usage problems which very many other researchers in neuroscience are struggling with other distributions or with doing like package manager-less software management. And as a consequence of that, I started porting more and more of the neuroscience software for Portage, like writing e-builds for it. They're all reposited in the science overlay, and there's more than 30 neuroscience packages along with quite a few dependencies. A number of them I've even contributed to the main tree. And a very good thing for myself, since I am on some of these packages also a developer, is that these packages include live e-builds. So me and my collaborators, if we really have one commit which we know solves one issue which we're really dealing with, we can install it via the package manager on all of our machines. NeuroGentoo is a word you might have heard. It's not something which I mean to be a separate distribution. It's not something which I mean to be a separate repository. It's simply a name which I gave to this small initiative of mine, mainly for marketing purposes. I want to convince other researchers that Gentoo is worth using for neuroscience and that it has very many benefits which other types of software management might lack. And to do this, I made a moniker which is similar to the NeuroDebian they know, and I even went forward to make an icon which is similar to that of NeuroDebian, which they know. Basically, the point of this is not to create a separate branding, but to make it clear to researchers when I go to conferences, when I make a poster, that this is the kind of thing you do with NeuroDebian. We can also do it, but in my opinion, we can do it better. And the roadmap which I see for this project, the things which I'd like to do in the coming months and which I'd be very happy if anyone would want to help me with, is I'd really want to take a look at improving the system replication workflow. The copying of Portage configuration files, which I showed you, works for me. It worked for me dozens of times. However, it is a bit clunky, I have to say, copying these files from left to right. And maybe it's easy for me because I've used Gentoo for a long time, but it would be interesting if we can make this easier for new users as well. And I'm also curious how long it would actually be feasible to make this system replicability, especially with view to versions, because older versions of e-builds get deprecated, they get deleted. So if you have like a publication which came out years ago, it might be a bit difficult to use the system which I just proposed to ensure that you can replicate the system on which you ran the analyses. You might not get around to doing binaries for that, but I mean, I'd really love your feedback on that. Not only that, but I'd like to test more system replication use cases. For instance, I tried to do it on Amazon, on OpenStack. It kind of worked, but apparently there's no official Gentoo Amazon image. There's another Pigocelis Papua, I think they call it, some other people who have an image, which however has a lot of Perl files, which I thought were useless, so I had to delete them. It would be really interesting to talk to the infra team about this and see how the status is of these images and see if I can really do the system replication based on the images which they want to put forward. I read an interesting paper which is in print or under review by some of the people who do Gentoo prefix. It would also be very interesting to test that out to see if you can really do a software environment replication on Gentoo with Gentoo prefix. And of course, I would be really curious on whether or not you guys have any experience with Docker, because I've looked at that. But from my point of view, Docker to some extent nullifies the entire purpose of Gentoo, because you have these binary containers which you stack on top of each other. I'm really unsure whether, how this is supposed to work with a built from source philosophy. I'd like to increase the visibility and accessibility of Gentoo for neuroscience. I keep talking about this at neuroscience conferences, but it would be really cool if I could get at least a wiki page or some presence for this project on the Gentoo web space. I don't think it should be a separate project from Gentoo Science in the same way in which NeuroDebian is separate from Debian Science for whatever reason. I think it'd be really nice to just keep it integrated with Gentoo Science, but I think it would help a lot if researchers had some sort of description of how exactly they can quickly use Gentoo on their virtual machines to improve their research. Currently, I'm writing all of the work up, all of my trials, as a small, how do you call it, as a small report for one of the hackathons I went at, but I think it'd be a lot better to have it on the wiki with, of course, contribution from the community. Not least of all, if anyone wants to help package more software, I'd be really helpful for that. There's always new packages appearing. For instance, Broccoli is very popular these days. It was first mentioned in a paper not very many months ago. It does the same thing which other GLM randomized packages do, but a lot better. And of course, some of the bigger packages in neuroscience still have issues. Like we provide them, but they don't really work very well. For instance, ANTS comes with a lot of bundled stuff, ITK. FSL installs fine, but the GUI doesn't really work, which isn't an issue for me and many of the other people working on headless servers, but some of our colleagues might need the GUI. And of course, there's AFNI, which is one of the biggest software suites for neuroscientific processing. However, they don't really have a working CMake build system. And the people in NeuroDebian want to work on this. Upstream wants to work on this. If we could also lend a hand, maybe everybody could finish this work faster. So having said this, I hope that I did not overrun my time too much, and I'd be very grateful to hear your feedback. Thanks.
Hi.
Hi.
So, totally separate issues, but I may want to end up asking, what impact have you seen on reproducibility via changing glibc? A decade ago, I ended up running a cluster for computational protein research.
Yeah.
And we ended up discovering, unfortunately, that changing glibc changed their results significantly.
Yeah, it's actually not an unknown issue. There's actually quite a few publications on this, at least one which tried to run a complex a neuroimaging pipeline on CentOS using different versions of glibc, and they also noticed significant difference in their statistics. And I think this is why it's important to have not only system replicability in the sense that you deliver the same packages, but also some sort of system reproducibility in the sense that you check that they are indeed the same versions of the packages. The people who are working on binary distributions, they have a lot of initiatives to make sure that their binaries are like bit by bit reproducible. Might be a bit difficult to do on Gentoo, or a bit easier because we document our compiling process a lot better than they do. But I am aware that this is an issue, but I think this is an issue which Gentoo is very fit to tackle, simply because Portage is very aware of the versions and you can't specify them precisely.
So the thing that ended up biting us there is that when we tried to pin glibc, we ultimately wound up needing a newer kernel that would work on the hardware that they were using, but old glibc didn't work anymore.
Okay.
And they just couldn't reproduce the results anymore.
Yeah.
I will hand up to anybody else with questions before I go into other topics.
No, so I mean, I get the point, and it's also part of what I said. I mean, reproducibility is important, but at some point it just falls apart. It's the same thing as with the old e-builds, which simply become deprecated. So I mean, yeah, I guess there's a half-life to replicability, and we have to live with that. But for as long as the software still runs on the hardware, I think it's important to provide systems which people can actually use to test literature results on their own machines, yeah, and I think Gentoo could help do that.
Questions? Someone? Okay.
Just a small comment that packages removal is not critical. You can always restore it from Git. You just have to build your system, record your hash of current commit, and you can restore it on any other.
Okay.
And another note, there are clusters running on Gentoo. I run several myself at my university, but even if you have an access to such clusters, there is still a problem with versions, because administrators will not allow you to install different versions if they can't coexist with current versions. So you have to use prefix or some LXC container. There is no other way.
Yeah, that's why I thought that prefix is very interesting from the point of view of clusters. And I do realize that you have this dichotomy. That's why I showed that like chimeric picture of the cow which can give you eggs, because on the one hand, you want your research platform to stay reproducible, but on the other hand, people always need cutting-edge software, especially in neuroscience, where people who do research do also develop a lot of the software. Yeah.
Yeah. Okay.
Any other questions? No? Did you want to say something?
I was just making sure I didn't monopolize it. As to your question about cloud image, an official answer from Infra, there are OpenStack images that we semi-publish. They're in experimental at the moment, but they will be moving to releases soon. And at least as of yesterday, the EC2 image should work.
Okay. I've actually talked to Promethean Fire about this not long ago, and he said that like my problem with the OpenStack images was that I could not get the SSH keys working. Apparently there was an issue with Cloud Init.
Cloud Init has been the pain in the ass.
Which should also be fixed now, but I think it'd be really interesting to actually try this out, because the way I've tried this out now and my colleagues have tried this out is I've made my own in-home Gentoo image, which I share to people, and then they simply copy the files on top of that and they recreate the system. But of course, it would be so much better if this works with the official Gentoo image, right? No.
Yeah. As I say, as of yesterday, the EC2 image should work.
Okay.
Anyone else? We have 10 minutes or something.
Oh, 10 minutes, okay.
Oh, God. 1 minute, yeah. We have
Okay, speaking for Gentoo Infra, can you tell me anything about Docker? Like, what's the current status of Docker for Gentoo?
Infra does not support Docker.
Okay.
If other people do, go ahead and use it, but Infra doesn't ship Docker images. We
Okay.
have no immediate plans to. There are people that use it and say stages work.
Okay. Yeah, that's as much as I thought, because I really don't see how the binary distribution model of Docker would be compatible with what I see Gentoo is trying to do.
As for the sharing the system configuration and so on, you said you wanted to move out from tweaking files in etc. Did you play with Portage profiles to make a reproducible, let's say, overlay?
I mean, the interesting thing with all of these reproducible systems is each scientist, when they have like their publication, they have the status of the system on which they ran it when they got their results, right? And ideally, there wouldn't be any live software on it at that point, but the versions might be very heterogeneous, or the libraries which are used might be very heterogeneous. So I don't know if like it's a sustainable thing to have thousands and thousands of profiles for this. I actually think it's not. I think you should there should be a way to like share this information without overcrowding any of the Gentoo infrastructure, and just have something which you can copy paste in place. I talked to someone who like not long ago here, maybe he's here, who said that he was working with Puppet and that might be useful for solving this issue, but I have no experience with that, so I couldn't say anything. No, neither do you? Do you know anything about Puppet? Like, would that be a good alternative for this, or?
Yes and no.
Okay.
We'll pass it up the microphone.
So the general issue that it will run against is that although you can pick a git commit of Portage that you build with, that does not mean that the upstream still offers the tar GC or these kind of things. And when you work with Gentoo machines that are older, you definitely notice that. So if you try to do anything that is reproducible, there's basically no way around than mirroring everything that's coming from external. And
okay.
Once you have that is the point where you can start taking git commit. And with a git commit, you kill off many of the problems already. So you can of course use Puppet, but the real hard part is getting all the third-party tarballs to just to be able to rebuild it.
Okay.
Anyone else? Okay, thank you.
Okay, so thanks again for your feedback.